Let's talk about that problem number 2 on our conclusion questions there. It says we have to use our graph to answer the question, and that it is estimated that the last magnetic reversal occurred about 780,000 years ago. So here you can see our data that I've already analyzed and marked up. And the question says that the last magnetic reversal, we know this mid-ocean ridge is where the brand new baby rock is forming. We learned that in large group. And then from the problem, it said the last magnetic reversal. So if this is today, the last magnetic reversal would have been that first line we drew on either side. So we know it took 780,000 years for the rock to get from the center point out to here. Because as that new baby rock just kept pushing and pushing, it moved outward. And so it took 780,000 years to get that far. And then it says, what is the rate of seafloor spreading in our model? And there's different ways to analyze it, but the sample that's given, and the last given that's given to us was that 1 centimeter equals 1 kilometer. And so if we're solving for y, as in the example, it said y equals the distance from the mid-ocean ridge. Now your first instinct is going to be to measure this distance, and I think when I measured it with a ruler, it came out to be about 3.5 centimeters. Now the problem with this is we measured, if you notice down here towards the bottom, we measured in centimeters. So depending on how you printed this, you could have printed it sideways and it's a little bit smaller. You could have printed it landscape and it's a little bit bigger. But each of these dots represents 1 centimeter of data that we measured when we took data. So this one is 1, 2, 3, 4 centimeters and a half, and I can count those dots because those were my data points, or I can look along here across the bottom. So my mid-ocean ridge falls right at 15 centimeters. It's not quite all the way to 10, so that's about 4.5 centimeters. If I go to the right, it looks like it's about the same. So there's 20. It's not quite all the way to 20, so it's about 1, 2, 3, 4.5. So I've got about 4.5 centimeters. But if you look on your lab, it says that 1 centimeter is the scale was also 1 kilometer. So 4.5 kilometers, and then the time it took was 780,000 years. Now, when I plug that into my calculator so that I can solve for y, I just take 4.5 divided by 780,000 equals that really tiny number. So now there's 1, 2, 3, 4, 5 zeros and a 577. And that's in kilometers per year. But that to me is too small of a number. It's too fuzzy. So the other thing I know is that there's 100,000 centimeters in every kilometer. So I'm going to multiply that by 100,000. And I end up getting 0.5769 centimeters per year. That's just on my data. Your data will use different numbers because you're going to come up with a different value here. This is just one way to solve it. It doesn't matter if you use my exact way. You can use whatever way. Like if you know how to solve, a car is traveling 60 miles per hour. How long does it go in 1 minute? That kind of problem, then you can solve this problem. Don't let the math scare you. And then for question 3, the real life application, what is the actual rate of plate movement in a year? For that one, please make sure that you Google that. And there's lots of possible different answers. Yes, I know. Do your best. But you'll be able to see very clearly whether or not our model was the same rate or different rates and whether it was faster or slower. Good luck, Warriors.